Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week of Weather. I'm your host and meteorologist, DT from Weather Risk, your commander of chaos, your colonel of confusion, your captain of catastrophe. Let's talk about this week in weather for January 15th. It's about 6:30 in the evening. Sorry, this came out a little than I thought. Had some behind-the-scenes issues, but things are working good now, so let's get right to it. So on this issue here, we're going to be talking about the January 19th, 20th Mid-Atlantic snow threat, the potential event, something, January 22, 23, 24, and the cold pattern coming to an end by January 30th, looks like. And again, all of these topics we talked about in the last couple editions of the the next 3 weeks newsletter on January 19th. We're talking about this for a while, talking about this event for a while now, and we hinted at last week on the new edition that looks like the cold pattern is going to come to an end by January 30th. This here is the website, in case you haven't seen it yet. And of course, you can get the 3-week newsletter here through the shop page, also the snow removal forecast, the Mid-Atlantic, and stuff like that. This here is the Weather is Grains Twitter page for my grain commodities clients. And this here is the Blue Sky page for the snow stuff and operational weather here in the eastern United States. Okay, so here's our MJO. Take a look at that briefly before we get into the snowstorms. Here we are right now in phase 1, which is pretty good for the eastern U.S. for winter and for cold. And phase 2 isn't too bad either. This is the GFS ensemble, which takes us to mid-February. And this is the CFS. But notice what happens once we get into the purple lines here, which is the week 2, week 3 forecast. So the red is next 5 days. The blue is the 6 to 10 day. Then 11 to 15 day and 16 to 20 day is the purple line. And you can see what happens is that it goes into phase 3, then phase 4, and phase 5, and even phase 6. And that's really bad if you like cold and snow, and this will take us into February. So that's what these two models are showing, and they're showing the pattern breaking down here. Now, the European is a little different, and the European makes it to phase 3, which is also not nearly as cold. It's not super warm, but it's not as cold. But then it turns into the neutral circle. It does not go into phase 4 or 5 or 6. So that is something that's significant. Obviously, these have big implications here, because from here, it implies that the MJO could, by late February, come back out into phase 7, 8, or 1 for late February and March winter problems in the eastern U.S. But we don't know that. I'm just saying it could. This, of course, is much warmer, and this would be both of these takes us to mid-February. So by the time the pattern will swing around, if this solution is correct, if the MJO does this, then it would be in phase 8 and 1 in late February and March. So we'll see how it plays out. All right, so that's one thing to keep in mind. And this just shows you what the patterns look like, 500 millibar anomalies in the winter months. Phase 1 we are now, which is the trough here, and going to phase 2, the trough in the Midwest. The plain states, which is in fact what we will see coming up here, no doubt about that. So keep this in mind. And phase 3, things begin to change a little bit. And then look what happens in phase 4 and 5. You get this big ridge in the eastern United States and some blowtorch. So we'll have to wait and see. Again, temperature anomalies, phase 1 in December, January, you can see how cold it is. Phase 3, a little milder, not too bad. It's still close to normal on the East Coast, a bit milder in the plains, the Midwest here, and then everybody, Midwest, the East Coast is pretty darn warm if we go into phase 4. But again, we don't know if it's going to do that. We'll have to wait and see. All right, let's take a look at our teleconnections, which are, again, significant relationships or links between weather phenomena, jet stream patterns, separated by hundreds of thousands of miles distances. We're talking about the jet stream and the big global patterns here. These are just jet stream patterns. There are also other, like the MJO, that is a teleconnection. Whether you have El Nino or La Nina, that's a teleconnection. But these are hemispheric teleconnections. And we have 4 of them which dominate the pattern here in North America. We have the Pacific side here, and we have the negative EPO and the EPO, the Eastern Pacific Oscillation, and the PNA, which is the Pacific Oscillation. Then on the Atlantic side, we have the Arctic Oscillation and the NAO. So let's take a look at them. These are our latest projections here, and you can see from weather models, here's the Arctic Oscillation and the NAO. So I'll put this in here so you can follow along. The Arctic Oscillation is connected to the polar vortex. When the polar vortex is weak, or if the polar vortex comes south, the Arctic Oscillation is more likely to be negative. Okay? A negative Arctic Oscillation favors below normal temperatures in the eastern U.S. and increased storminess in the wintertime, increased chances of snow and ice. A positive Arctic Oscillation favors above normal temperatures in the eastern U.S. and less storminess and more activity in the western U.S., west coast, Rockies, and the upper plains. So as you can see right now, there's the dots, the black dots, that's where we have been. Now it just moves slightly positive. Then for the next 2 weeks, notice what we do. We bounce around here, but negative, positive, for all the way to the end of January. So pretty much neutral with minor oscillations here on the different models. Now the North American oscillation, that is what's known as the Greenland block, but actually covers northern Quebec, Labrador, Greenland, and Iceland. Now, the NAO may or may not be in the same phase as the AO. It may not. We don't know if it is. It can or cannot be. Sometimes it is or isn't. A negative NAO favors below normal temperatures in the eastern U.S. and increased storminess, especially when the NAO is is combined with a negative AO. When these two are combined, you really have a good pattern, which is what we've had now. And you go back here in January when we had the storms in January 5, 6, and January 11, 12. Look, the NAO was negative and the Arctic oscillation was negative. Now what happens is we're out neutral, and then again go slightly negative, then positive, then negative. So pretty much close to neutral here. And of course, the positive NAO, that favors above normal temperatures in the eastern U.S., but below normal in the Midwest and the plains. And East Coast low pressure systems usually track inland when you have a positive NAO. Okay, now let's talk about the Pacific side. So the EPO is the Alaskan Ridge or Trough. It may or may not be as the same phase as the PNA or the Arctic oscillation. A negative EPO favors below normal temperatures in the eastern U.S. and increased storminess, especially if you have it combined with a negative AO. And strongly negative EPO's eastern Pacific oscillations can lead to severe cold in the eastern U.S., which is exactly what we are going to see coming up here in the next few days. The neutral, then boom, it goes strongly negative. And it stays negative, begins to go back to neutral a little bit by the end of the month, but it's pretty negative here for the next 10, 12 days. Now the PNA is the West Coast Ridge or the West Coast Trough. A negative PNA is a trough, which favors below normal temperatures on the West Coast and the Rockies, with increased storminess from the West Coast into the Rockies, the plains, the upper Midwest. It will also cause a ridge in the eastern U.S. and the Southwest Atlantic. So what happens is the low pressure areas stay to the north and it's above normal with below normal temperature precip in the eastern U.S. Now a positive PNA is when you have the ridge on the West Coast, and sometimes if the ridge extends up to Alaska, you can have a very strong ridge, and that favors below normal, or sometimes much below normal, in the central and eastern U.S. Now, a purely positive PNA can lead to, that is to say, with no other teleconnections, just a positive PNA, can lead to below normal temperatures and below normal precip on the east coast of the Midwest, because you're getting strong northwest flow, and the southern jet stream doesn't get involved, so it's just cold and dry, which is what we saw for most of December. Just cold and dry. Okay. So that's where we are. And you can see here the PNA, again, we were positive, now it's neutral, and then it kind of stays neutral and then begins to drift by the end of the month towards negative, which indicates it may be a trough forming by the end of the month on the West Coast, which is the beginning of the pattern change. Okay, let's talk about January 19th and 20th first. So this here are the upper air maps. Okay, there's only 96 hours out, 108 hours out, so we're getting pretty close to this event. Now there's your polar vortex right here in Canada. It's actually a piece of the polar vortex at 500 millibars. It's not the quasi polar vortex at 10 millibars. It's not the normal one we're talking about. So this is 500 millibar polar vortex, a huge upper low here, very cold, dropped down from the Arctic region. And you can see this massive trough here. And look at the lines. Let me blow this map up so you can see it a little bit here. Bring it front so you can see how impressive this is. Okay, so you're getting your flow here. Bring it to the front. Okay, coming out of Canada. Now this ridge is built from the west, from eastern Pacific into western Canada, and it's almost meeting the Greenland block. So you see how you have this linkage here, and that forces the polar vortex south, and the Arctic air comes plunging south. Now look at these lines coming out of the North Pole and Siberia. Look at all these lines. That's straight Arctic air, unbelievable. Now this is your trough axis. You see how it's tilted? The trough comes down here, and then it changes direction. It comes down here, then it changes direction by the lines. So there's your trough axis, and your low pressure area is going to form somewhere on this front. So this is now Sunday morning. The Arctic front is pushed to the east coast, and it's stalled here on the Georgia, Carolina coast. And that's where your low pressure is going to form. But then you have a second disturbance up here in the Great Basin, Nevada, Idaho, California. That's your event for January 21, 22, 23, depending on how that plays out. But this is your main trough axis right here, and that's where the low is going to form. Now, that's the European. The GFS is showing the exact same thing. Now, the only difference here is that the GFS has a little less energy up here in Idaho. But other than that, it's got the exact same trough axis. Okay? So we're pretty good agreement with these models. Now, here comes the cold front on Saturday. Okay? Saturday is going to be a pretty decent day before the rain hits. Friday as well, not too bad. Okay? We're getting southwest winds. The rain will be mostly snow in northern Ohio Valley, eastern Great Lakes, maybe the mountains, and then northern New England. East of the mountains, it's rain. It could end in snow in a few places in the high interior of the mid-Atlantic and New England, but mostly rain. And then the cold air begins to come in Saturday night. Now, here is the GFS. This is the 12Z GFS. It develops the low along the Carolina coast, and you can see moderate snow in western North Carolina, north central North Carolina, into central Virginia, eastern Maryland, Delaware, and then moves off the coast. And the heaviest snow staying south of, according to the model, D.C., Baltimore, Philly, and New York. Southeast New England would get clocked. East Long Island would get clocked. Okay, and the Delmarva would get clocked again. That's according to the GFS solution at 12Z today, Wednesday. Now, this is the European solution. Same thing. Now, the low is a little closer to the coast. The European has a little stronger low here, and it's got more widespread. Now, it's still raining in southeast North Carolina, southeast Virginia, and most of the Carolinas here. But you can see the moderate snow developing the Shenandoah Valley, central and northern Virginia, the Maryland, Delaware. You can blow this up a little more. This was the 6Z European from early this morning, and you can see the moderate snow band right here. And again, just to the south of the big cities here, then up towards Boston. Now, the 12Z run is a little further inland, and you can see the difference in the snow maps. So this was the 6Z run here, and notice the snow is a little further inland here. Again, not a big event. This is talking 2 to 6 inches, from what I can see here. Very fast-moving system, not a big deal. So there is that. And now this is the GFS. The GFS is a little more concentrated here. This is the 12Z GFS, and you can see it's got a nice snowstorm for Richmond and Lynchburg and Charlottesville, but it stays south of D.C. and Baltimore and Philly and New York. You can see that right here. And that is accumulating snow in Hampton Roads and in Williamsburg and in the Middle Peninsula, places like that. So maybe. I can't rule it out. I think this is a little fast, but it's possible. So our variables are this. Okay, this is our summary of the January 19th event. First, where does the low form on the cold front? All right, let me call up a marker here so you can see it. Let me take this one out and put it here. Okay, so we can follow along. Okay, so that's the first point. If the low pressure area forms too far inland, the temperatures might not be cold enough in eastern Virginia, eastern Maryland to support all snow. Okay, in this scenario, if that happens and the precipitation begins as rain, ends as snow, and all the accumulation will occur in Roanoke and southwest Virginia, western North Carolina, the Shenandoah Valley, the eastern portions of West Virginia, northern Virginia, western and central Maryland. But some of the models have the low forming on the coast. Okay, if so, then the cold air does reach central Virginia, Lynchburg, Charlottesville, Richmond, Fredericksburg, and northern Neck. And they would see mostly snow with some accumulation in these areas. But then D.C. might not see as much, or Baltimore or Philly. The other question is, how fast does the cold air come into Virginia, Maryland, and western North Carolina Sunday morning? The models keep flipping back and forth with how fast the cold air gets and how deep it is. So the Sunday low snow threat does not look like a type of storm that's going to bring any snow to Hampton Roads or southeast Virginia, eastern North Carolina. But that is assuming the European model solution is correct here. The GFS could be. So don't hold me to this. This could change, all right? I'm not saying no. Right now, it does not look that way. Let me just change this and say it does not look like a type of system for Hampton Roads as of right now, okay? I think what would happen is you're going to get rain, which will end as snow. And you could get an inch in Hampton Roads. But it does not look like a big snow to me right now. Maybe this scenario is correct. I don't think it is, but we'll see. Okay. Now let's talk about January 22, 23, 24. Okay. This is a complicated situation, so pay attention here, boys and girls. All right, here's the European model valid for Monday night, Tuesday. So there's your polar vortex. still in Hudson's Bay, Canada. And then you can see the trough. Let me blow this up a little bit so you can see what I'm talking about. Okay, so here, bring it forward. There we go. So there's your trough. Okay, now what happens is a piece of this energy hangs back here. And the reason why it does that is because of what we saw here on the European. You see that piece of energy right here coming in Idaho? That drops down towards Arizona and New Mexico, and it changes the shape of the trough after January 20th across the Midwest and the Plain States. So that's why the European is doing this. That's that piece of energy in Idaho, Nevada comes down here. And it extends the whole trough like this. Okay? So the cold air is coming down this way, and it's coming down to the southwestern states. Now that means you're going to have a front running across the Gulf Coast. This is a huge upper low, huge trough here that pushes the Arctic front, not to Virginia, but down by Georgia and Mississippi, Louisiana. All right? Now that's what it's doing. Now what happens is, here the European model separates. This piece of energy separates, and look, it pushes actually towards Baja California, completely separating from the main trough. As a result, any low that forms in the Gulf Coast is going to be sheared apart and not organized, and it's not going to do anything. And that's exactly what the European was showing from early this morning, 0Z and 6Z. Now the 6Z is a little bitter, a little stronger. This is the 12Z, I should say. Okay, so this was the 6Z here, and there's the 12 European. Okay, but notice the high is in the Arctic high is in West Virginia or Ohio. So you're not going to get the snow. If this is correct, the snow is only going to make it up to eastern and southeastern Virginia. So we'll see. I don't think the solution is correct. I think the European is way off here, and I'll explain why. But that's what it's showing. All right. Now, the reason why I say that is because this is the European ensemble. Val the same time, Tuesday, January 21. So this matches, let me bring this one forward. Okay, matches that. Now you see the upper low there in the southwest, I circled it, okay, in Arizona and Baja California. That's not what this is showing. The European ensemble does not do that. It keeps the trough together. So as a result, you have an organized low pressure somewhere in Texas or along the Gulf Coast. And the trough axis, the thick black line here, okay, continues to progress eastward, carrying the low with it. Now your polar vortex has now moved up into Quebec and northern Labrador. And it's still very cold. You're still getting direct flow of Arctic air out of northern Canada. But the reason why that's important is because then by the time you get to the 22nd, you now have a unified trough here. Now it's positively tilted. You see how it's running southwest to northeast? It's positively tilted. So it makes a difference. Where does the low form? If the low forms in Louisiana, look at the flow. The flow is west to east. See this? West to east. Well, maybe west, southwest, east, northeast. So you only get a little bit of latitude. But if the low forms in Oklahoma or Arkansas, then you have a track which is going to bring a snowstorm to the Ohio Valley, Mid-Atlantic, and maybe even southern New England. It goes straight across west to east. You don't get any latitude here with this because of where the low forms. So we don't know. Is the low going to form here? Is it going to form here? I don't know. I can't tell you. I don't know. Okay? Now, the polar vortex, again, is in northern Quebec and Labrador. Your block is still there in Greenland. But your ridge, look at your ridge. Your ridge is beginning to shift. The ridge is being expanded now towards Alaska. That's not a good sign if you want the pattern to stay cold. Okay. And then now this is the GFS. We saw what the European was doing, okay, which was crap. Look at the GFS, the operational GFS. It does not have this piece hanging back here at all. It's got the main trough axis right here, the Mississippi River Valley, and as a result, notice the flow. See how the flow's up the coast? So now you have low pressure of the Gulf Coast, which goes up the coast and crashes into the Arctic air, and you get a snowstorm. Bada boom, bada bing. 6Z, 12Z GFS. Bada boom, bada bing. Okay? Now, we don't know if the low is going to be in Raleigh or is it going to be on the coast. We don't know that. If the low is going to go east of Norfolk or go over Richmond, I don't know. Nobody knows. But it has a significant event. Why? Because it doesn't have that energy hanging back here. You've got a unified trough, and the flow is going from southwest to northeast into the Arctic air. Okay? Lots of Gulf moisture, Arctic air, winter storm. It's not rocket science, boys and girls. It really isn't. Well, sometimes it is. Okay, so the summary for January 22, 23, 24, what do we know? We don't know shit. We don't. Okay, I believe the European is wrong. The European has always had issues with short waves in the subtropical jet, okay, and the southwest CONUS, always. Okay, the recent model upgrade did not fix this at all. So this still is a problem. The 6Z and the 12Z operational European clearly screws up the shortwave in the southern tropical jet, so the model does not have any kind of low in the Gulf of Mexico or the southeast U.S. on January 2, 23. The EPS is very different, which tells me that the operational European run at 0Z, 6Z, 12Z is Bravo Sierra. Just BS. Okay. So if the operational GFS is correct, if the, should say, the GEF, okay, the GFS ensemble and the EPS are correct at 500 millibars, see slide 22, 23, 24. If this is correct, if this is correct, if this is correct, then you get a snowstorm on the East Coast, or at least a part of the East Coast. Okay? The other option is a compromise, where the low forms in the southeast U.S. Gulf Coast, but it only goes up so far up the coast because the flow is too strong from west to east. It takes it off the coast. This would screw New York City, maybe Philly, and New York from a big storm. They might get something, but not a big storm. So that's another possibility. Okay, that's where we stand. I can't give you any more information on that. It's too up in the air. Okay? So, and then finally, there's another event potentially showing up January 24, 25, which again, which is what I talked about in the newsletter back on yesterday, and then the one from last week, there is a third event, okay, and also the update on the Facebook page. You can see that there's one more shortwave trough coming in here. But this is the end of it, because look what happens. Once the polar vortex goes up to Greenland, the NAO goes positive, the Arctic oscillation goes positive, the pattern collapses, and we turn mild. All right? So that's what the GFS is showing. The European is, again, screwing it up. You can see it still has another piece of energy hanging back here in northwest Mexico. This is just, no, this is wrong. All this is wrong here, so I'm just ignoring it. But you can clearly see, and again, you know, if we go into the mild pattern, we are going to get definitely milder. The question is it going to blow torch, or is it just be, you know, a little mild? So that's what we don't know, but we'll see. We'll get to that next time. Okay, there's the update. This is meteorologist DT from Weather Risk. I will see you over on the Blue Sky page, and then over on the Facebook page and the website.